Hi everyone, and welcome to Data Science Dojo's live tutorial on an introduction to data visualization with R and ggplot2. My name is Blair Heckel, and I'm the Senior Marketing Manager here at Data Science Dojo, and I will be moderating today's webinar. Our presenter today is Arham Akheel, Business Analyst and Instructor at Data Science Dojo. Arham holds a master's degree in Technology Management from Texas A&M University and has a background of managing information systems. Prior to joining Data Science Dojo, Arham used to manage operations for a startup in India. He then went on to work as an applications engineer. Arham joined Data Science Dojo to realize the company's mission of data science for everyone. It is Arham's belief that you do not need a PhD in statistics or machine learning to learn data science and apply it to your daily work to derive business value. Arham has experience managing information systems, and his current focus areas are teaching, data exploration, and marketing. Arham's true passion, however, is to work with emerging technologies of the world. Arham, welcome to this Data Science Dojo webinar.
Thank you, Blair, for the introduction. It's a pleasure to be presenting today, and thank you all for joining in. Before we get started, I actually would like to set some expectations. So I'm assuming that you're experienced with R coding. In the sense that you're not an expert, but you know R code when you see it in a hacky way, like you know how the syntax is, how R code is written, just the basics of it. Not expecting that you're an expert, just basic R coding. So, and I'm also assuming that you have some data visualization knowledge. What I mean to say is that you know what a histogram means, what a box or a whisker plot means, just general knowledge about how visualization works, like what are the kinds of plots you can actually create. And I'm also assuming that you're interested to improve your data visualization skills with ggplot2. That is, you actually have interest. You're either an aspiring data analyst or a data scientist, and you want to get into this field and analyze some real world data. So, and also I will actually be focusing on the 20% skills required to get you started, the basic skills which are needed to create a plot. I'll be focusing on that, which will be useful most of the times when you're creating a plot. Instead of diving into advanced features and functions, let's just look at the basic 20% of what you'll be using in ggplot2 to create plots. So my basic idea is to just help you create plots and get you excited about ggplot2. If you're just starting out as a data analyst or a data scientist. So, and I will also briefly go over, just look at how, if you don't have R or RStudio, I will just briefly show you how to download R in RStudio, but very briefly I will just gloss over it. Moving on, there are some prerequisites here. Like I mentioned, I will briefly show how to get R in RStudio, but it's a basic prerequisite. So if you have it installed, you're in the right place. If you know some R code and trying to learn ggplot2, you're in the right place. It's better if you have the ggplot2 package installed in your R environment, because it's a little bit bigger package, so it takes some time to load up. So if you have it pre-installed, it's better. You can follow along the presentation, and the files which I'll be using through this presentation are available on the GitHub repository. It's called github.com/datasciencedojo/tutorials. We have most of our tutorials checked in there, but you can find the data visualization folder which has the files in there. I will also briefly show you and go through the files in my presentation. So moving on, we will be using the Titanic disaster for machine learning dataset in this presentation. We'll visualize the Titanic dataset. And let's ask ourselves this: why this data set? It's a very common data set out there. Everyone is familiar with the problem, and everybody knows how the data looks like. When I actually ask people, they always come back with the answer: does anyone know Titanic, the situation and what happened at that time? Most people say yes. So it's best to actually explore the data set with something which you already know if you're starting out. You can explore the package ggplot2 with a known data set and then move on to some real world problems. So again, it's a proxy data. It's common enough that everybody understands it, and most businesses actually have customer profiles similar to the Titanic data set. So most people have name, age, gender. So that's most of the customer profile data. So it resonates with most businesses, and I feel like this is a good data set to start with. We will also be using another data set in this presentation. At the end of it, we will briefly go over a few plots with the H1B data set for 2018. For those of you who don't know the H1B data set, it's a public data set provided by the US Department of Labor for the applications filed for foreign workers to come work here in the United States. And it's a very popular topic. It's a huge data set. There were more than 400,000 applications this year, and which will be reviewed, and close to 65,000 of them are picked out from those. So it's a huge data set, like I told you. So it has about 52 columns and more than 400,000 rows. The metadata for this data set is also checked into the repository. So if you want to know which column, what's each column, like case number, case status, what does it mean, you can go through the metadata, and I will also briefly go through it. But of course, because of timing, we just have an hour. So because of timing, we won't be able to go through the advanced functionality. So I will just gloss over a few things. But we will look at some employment trends in the United States for foreign workers, just basic trends, and we can follow along with those plots and look at the story. What story does the data say there? Okay, let's move on to ggplot2. What is ggplot2? It's a visualization package in R. It's the standard package people use for visualizations when you're using R. So if you look at some of the social media articles or like magazines, people who are into data science, if you look at a plot in one of their articles, it's most likely 99%, I can tell you, that they're using ggplot2. So it's basically a de facto standard in the industry, that if anybody is using R and they're data savvy, they're using ggplot2 for plotting. So as you can see here, if you go to the R console and get the help file for ggplot2, it says create elegant data visualizations using the grammar of graphics. And what is the grammar of graphics? It's basically short of GG here for ggplot2. That's what is grammar of graphics. It's basically, we will look at the next slide and see what actually is the grammar of graphics. What are the basic aspects of the grammar? We will just lay it out in categories. And the basic usage of this package is to design print quality plots in seconds. It takes very few keystrokes in ggplot2 or on the R environment to create plots. I mean, it's easiest. I've used other tools too, like Tableau, Power BI, many other tools. This is the most customizable. It has fine-grained control via API. I mean, you can have as different kinds of themes. You can control the color. You can control the backgrounds. You really have that fine-grained control. And if you want to print out a poster, a huge poster, that is also possible using ggplot2. So you get print quality, fine-grained plots in seconds. It's really fast. In very few lines of code, you will be able to get up and running with any kind of plot you would like to create, and you can tell your story to the world or your company or to whoever wants to know more about your data. Okay, so let's discuss a little bit about the grammar here. So every visualization in ggplot2 is comprised of few things actually. There are about 6 aspects to it. So the first one is data, which is the raw material for your visualization. It makes total sense. You have to have your data for visualization. So no data, no visualization. You don't really have any visualization if you don't have data. Next up is the layers. So it's actually the points, the lines, the bars on your chart. So whatever, the way you want it, those are called layers. So if you're having a bar graph, that's a layer. The bars on your plot is a layer. If you're having a line graph, the lines on your plot are layers. So moving on, you have scales. You can think of it like the scales, the numbers. What would you like the numbers to be on the x-axis? What would you like on the y-axis? Is basically to map your data in a graphical output. So you need a specific scale to output your data on a single screen or a single plot. So of course we have data in a spreadsheet. We are able to look at the data. We have to scroll through the entire data set to know more about it. So how do we bring it down? How do we condense it into one visualization? With the help of scales. I mean, so you have scales and you condense your data down within a certain scale and you represent it graphically. That's one important aspect of visualization in ggplot2. Another one is coordinates. So the coordinates, you can think of it in a 2D context. X and Y are your coordinates. The coordinates which map the plot on ggplot2 or R. Those are specific coordinates. The X and Y are coordinates. That's in a 2D context. You can think of that. Next up is faceting. So faceting actually provides. It's the easiest way to basically drill down on your data, and it's the easiest way to basically think of pivot tables in Excel. So it's basically visualizing the pivot tables, condensing them on one screen. So you're able to embed multiple plots with relationships in one frame. We will look at faceting in the R code in some time. And the last aspect of the grammar is themes. You should be able to control your plot with fine grains. I mean, so if you want a yellow background or a pink background or a green background, you should be able to control it. You have fine grain control over all the aspects of visualization on your plot. So everything is taken care of with fine grain. So you must be thinking, looking at all of these, oh my God, this is complicated. It's getting hard. I thought ggplot2 is easy, but I'm going to go in for a complicated webinar. So let me tell you this, that it's much easier than it looks. It's working with the grammar is very simple. So you don't need to take into consideration all the aspects, but some basic aspects which you can get started with are, the first one is the data. No data, no visualization, which is your raw material. It's quite easy actually. And the second one is the aesthetics. It's the mapping of your data to the visualization. You map your data with an X scale equals to a certain column, a Y scale equals to a certain column. So you map your data to a certain plot with specific columns. That's the aesthetics of it. And the third one is the layers. What would you like? Would you like a bar graph? Would you like a histogram? Would you like a line chart? I mean, so it has different layers. And ggplot2 specifically has functions which start with geom. It's mostly geom underscore histogram or geom underscore bar. So most functions in ggplot2 start with geom, which we'll look in a minute. So if you know these three basic aspects of ggplot2, you're easily able to create a plot. You don't need to go advanced to start out. It's just an introduction. Let's start slowly. And let's move on to some of the resources available out there. This book was written by Hadley Wickham. He's the creator of the ggplot2 package. So who better to teach you ggplot2 than Mr. Wickham. He's the best person to guide you through learning ggplot2. And you might think this is a very complicated book for advanced functionalities, but this is actually a very good book, really good resource to get you started. It has very simple instructions and also advanced functions explained in a very simple way. So this is an excellent resource, hands down. So if you're planning to go deep into your data, you would really need to visualize it, explore your big data, as we say it. This is the book to get and start out. Okay, so let's get started with some R code. Let's look at some basic plots and get started with visualizing a Titanic dataset. But before we get started, let me briefly go over how to download RStudio. If you just go to Google and search for download RStudio, it's very simple here. The first link that opens up is RStudio. Scroll all the way down. Based on your operating system, you can choose the appropriate RStudio and download this and install it. So another thing to do is, so R is a prerequisite for RStudio. So RStudio is just a GUI on top of R console. So you would have to install R here before you actually install RStudio. And of course, like I mentioned, you also have to get the ggplot2 package, which we will look in a minute. And let's move on to the GitHub repository where I have all the files checked in to go through the webinar. It's again github.com/datasciencedojo/tutorial. So when you get into the repository, you have many tutorials. We have quite a few video tutorials. If you'd like to go look at them, we do have them on YouTube and other websites too. Within this, we have Introduction to Data Visualization. These are the files we need for the webinar checked in here. If you look at this is the R script which you need. The slide deck is available here. And the H1B dataset is actually a huge dataset. It's more than 100 MB. So I've added it into a zip file. You may need to download and unzip it. And the metadata for H1B is available here. It's a pretty comprehensive metadata file. So you know what each column means exactly. And you actually have a visualization here to look at what kinds of plots you can make, which we will go through at the end of the webinar. And at the end of it, we have the Titanic dataset. Let's look at some metadata. Let's look at the data dictionary for Titanic dataset. So I'm actually on the website Kaggle, which hosts machine learning competitions. You can actually go and create your own competition for machine learning. This is a very famous competition. So let's look at the metadata here. First up, you have survival. This is the basic question which was asked, whether the passengers survived or died. And there is P class. P class is the class the passengers were in, 1, 2, and 3. As you can look here, 1 equals the first class, 2 equals second class, and 3 equals third class. So that means that depending on the number, the passengers were in that class on the ship. And survival obviously actually means whether the passengers survived or died during the crash. So it's basically in binary. So 0 equals no, they didn't survive, and 1 equals yes. And so these two columns in the data set are actually non-numeric. So if you look at it, this is did not survive and did survive. It's yes or no. So these again here, 1, 2, and 3 they're numeric, but they're actually meaning something. So you cannot actually run numeric functions on it. So what I mean to say is you cannot actually multiply or divide these values because it wouldn't make sense doing that. So you cannot run mathematical functions on these two columns. Even if you did, it wouldn't make sense. So these are some of the important fields we'll be looking at during visualization. And moving on is the sex column, whether the person was male or female. It's very basic, straightforward. Age is in numbers. Obviously, it's a numeric field between 1 to 80 or 100 people being classified by their age. SIPSPA. This looks a little bit confusing. This actually means that how many number of siblings or spouses are you traveling with? So which equals to a number. So if you have one brother and a wife, you would be traveling with two people. So the number would equals 2. And again, similar field again here, Parch. Parch is again the number of parents and the children on board along with you. So you're a passenger and the passengers traveling with you. If you have parents or children, you would have the equivalent number in this field. So these fields are actually numeric, and you can actually run numeric mathematical functions onto these fields. Going forward, ticket number. It's obviously a unique identifier. Each person has a ticket, and just as an identifier, we have a ticket number. And passenger fare, it's the amount passengers paid to get on board the Titanic in pound sterling. It's the amount there. It's very straightforward. Moving forward, cabin number. Cabin number actually has most people have cabin numbers, but there are few passengers on Titanic that do not have cabin numbers. They were not allotted a cabin, so there are some empty values there. Embarked is the port of embarkation. So if they boarded on the Titanic from Queenstown, Cherbourg, or Southampton, the values would be equivalent to C, Q, or S on the dataset. So this is the data dictionary. This is what the data means. You can visit the link, take a look at what these columns mean if you don't already know the dataset. But I'm assuming most of you know what this dataset means, and you've actually looked at it earlier because it's a very common dataset. I'm assuming that you looked at it. Okay, so let's get into the R code now. This is the RStudio console here. I've loaded up the script, checked into the GitHub repository, and I will actually set up my working directory now. So it's the first line of code. I've checked into the script, which will actually set your directory, working directory. Let's run this and make sure we have all the files here. And as a prerequisite, obviously, we have to install the ggplot2 package. I'm also using the dplyr package to subset some data at the end of the webinar. We have some advanced plots, so I will be subsetting them. So it's best to also install dplyr. It's a smaller package. And by the way, dplyr was also created by Hadley Wickham, and both packages really work with each other in terms of passing functions as well. So I've already installed my packages here, and I will load them up now. Okay, let's double check if these packages were loaded. If you see a check mark here, it means that it's loaded. Let's go ahead and load a Titanic dataset. We can also view it at the same time. Okay, you might have noticed we did not look at passenger ID and name in our metadata. It's mostly because these are passenger ID is a unique identifier. Again, it's equivalent to ticket number, right? I mean, so these are just random numbers. These are random numbers to identify the row. It's just an ID to the data set for each passenger on the Titanic. So of course these are not very useful because these are unique identifiers, so we wouldn't be using these for visualizations. And of course, if you're doing some text analytics, maybe you might need the name. You can parse some data, Mr., Miss, and surnames into new columns and work with these, but we would not actually basically need it for visualizing our data. So let's move forward here. So a few fields here which we'll be using to visualize, let's set them up as factors. let's set levels on our data. This is basically the format of your data. Is it a numeric column? Is it a categorical column? So you're basically defining it as a factor that P class, survived, sex, and embarked are categories in my data set. So let's go ahead and run these. Okay, I see that the data set is loaded here, and we have set up most of our fields as factors. Let's start with asking ourselves this question, or let's start with some context here. Let's set some context. Let's have a context of you were hired by the cruising company to basically find out what was the survival rate. We have this data. The cruising company wants some answers. What was the survival rate? Why did the crash take place? So they want answers. So of course you can answer a few questions looking at the data. There are things that you cannot answer. So depends on what data you have. So let's ask ourselves this question. If you're a data analyst or data scientist working for the cruising company, looking at the data, what was the survival rate? Okay, let's start with a basic plot. So like I mentioned on my slides, we will start out with three aspects of ggplot2. The first thing is the data, which is the Titanic data set, which we are using. It's loaded up, ready to go. The second aspect is aesthetics. What columns or what kind of visualization we need to create. So point the column you need to visualize in aesthetics. The third part is the layers. What kind of layer do you need? Do you need a bar graph? Do you need a histogram or a box plot, a whisker plot? What do you need? So you define these three aspects to create a basic plot. Let's actually look at it. Let's use the help function in in R to look at what is ggplot2. It's really simple. Just type question mark and type the package or the function name. Oh, cool. I think we saw this earlier. Create elegant data visualizations using the grammar of graphics. It's pretty straightforward. Let's look at AES. What is AES? Okay, aesthetics. Construct aesthetic mapping to your plots. It's a function in the ggplot2 package. This is great. So this help function really helps if you're starting out as a data analyst. Always use the help function in RStudio or R. It really helps you figure out what you can do with a specific function or a specific package. So let's again look at geom underscore. Wow, if you look at this, there's so many functions here. Geom underscore crossbar, density, dot plot. There are a bunch of visualizations you can go through. So wow, it's never ending. So let's look at bar. You get a basic definition of what this function can do and how you can use it syntactically as well. So go ahead and feel free to use the help function whenever you need some in-depth knowledge about a specific function. So that's the best way to learn. That's how I learned it. I mean, that's to get started. Everybody not always starts out by getting into a course or coming out learning in a professional way. Most people learn the hacky way just by Google searching it and getting some help here and there. So this is one way of getting help within RStudio. Okay, so now we know how to create a basic plot. So let's go ahead and run this and see what the data looks like. What's the story behind it? Let's try to answer this question. What was the survival rate? Okay, so looks like 0 equals dead and 1 equals survived. So looks like there was a less than 50% survival rate during the crash. It's a basic plot. We have a certain understanding now that most people aboard the Titanic did not survive. There was a less than 50% chance. So let's look at what that percentage is. If you really want the percentage, you can also get it on top of these plots, but that would be an advanced function, so I'm not really going for that at the moment. Let's actually just look at a basic line here and see how we can get some percentages here. Based on the data set and the column, we actually get some percentages running this function here. Okay, so it gives us 61% died and 38 survived. So we were right. I mean, it's less than 50%. Okay, so moving on. Next up, let's get some customization into this chart. It looks very basic. We know the basic functions in ggplot2 now. You know how to create a basic chart. Let's actually copy paste and reuse this code. It's really simple. It's better to actually copy paste and reuse all the time. So you start out with the basic plot and keep adding to it. Copy paste it, and let's add some theme to it. So theme underscore BW is basically giving you a theme. This is actually a pre-installed default theme in ggplot2, which you can use. You can also use other themes, customize it, get into advanced functionalities, but this is a basic theme we will look at. And so this is the data. Our aesthetics is, the aesthetic mapping is at survive. It's very similar. And we will be doing a geom bar plot. And let's add some labels. This actually says count on the y-axis, so let's change the label to passenger count. Let's make it more customized. Let's add a title as well. So let's go ahead and run this plot. So we have some customization to this plot. Okay, it has a nice white background now. We have the label here. We have some title. It looks better. There's some control now at the moment. Okay, let's move on. As a data scientist, let's ask another question. What was the survival rate by gender? Okay, it's basic to ask that, because on board a ship you would expect children and women to get better treatment. Maybe they got off the ship on lifeboats a little faster than the male passengers, or is it the other way around? We don't know at the moment. So let's actually explore in that area. Let's look at whether there is a difference in survival rate based on gender. So again, how we can do that is using the fill function. Fill function basically adds more drill down to your chart by color coding it. So if you look at this bar, you would be able to color code it based on whether a person survived or died on male and female division, because X actually we've set it to sex, so we would get male or female on the X-axis and survive on the Y. Let's go ahead and run this code and see how our plot looks like. Oh, okay. So again, let's look at the story here. Wow, if you're a male passenger, there is less likelihood of survival. Of course, yeah, I think we were right. And male passengers were not really given a chance to go get off the Titanic during the start. I think female passengers and children were given advantage. So the survival rate is more if you're a female on board the Titanic. So this is great. We are getting some facts from the data. We have some facts to present to the cruising company now. What was the basic survival rate? We've seen that survival rate was less than 50%, close to 38%, and most female passengers survived. So there is I mean, less than 50% actually died. So there's more likelihood of female passengers to survive on board the Titanic. Wow, there's a high likelihood of not surviving if you're a male passenger. That's something to note if you're exploring this data set. Okay, let's move on. Let's ask another question. As a data scientist working for the cruising company, is there a difference if you are in a different class? If you're in third class, you might be way below in the ship. You might be down, so it might take some time for you to get outside on the deck and get on the lifeboat and move on. So I think there is a likelihood that based on your class, if you're in first class, you might have a better chance of surviving. Maybe so. Let's look at it. Let's look at, is there a relation between survival and the class? Again, you can actually see that this is copy, paste, and reuse. It's a good way to do it. Most functions remain the same. Labels change based on what the plot is, but most functions actually remain the same, and we are just switching the x-axis here to P class. Let's go ahead and run this and see how our plot looks like. Yeah. Wow, okay, so looks like we were right. I think third class passengers, most of them did not survive. If you're in first class, there's a highly likelihood that you will survive. There is a chance, and kind of 50-50 chance here if you're in the second class. Let's zoom into it. You can look at it. It's a beautiful, beautiful plot. You're able to customize the background. You have some labels here. You can name it however you like, and the title here. If you can look at it, we're slowly looking at the facts in the data. We know that gender plays a major role, and now we know that P class also plays a major role in your survival if you're on board the Titanic. So there are two features we want to explore, drill down further and see if there's a relation between these two or not. So how do we do that? Let's look at another question here. What was the survival rate by class of ticket and gender? Let's drill down and find a relation between both these features, class of ticket and gender. So here I will actually introduce a new function which is called facet wrap. I did mention it on my slide briefly that facet wrapping is basically embedding multiple plots onto a single frame so you can see the relationship between those columns, or is there a relationship? So you will see that again I've just pasted it and reused it. It's the code is very similar except that I've actually just added the facet wrap function. If you look at this squiggly line here, you can actually, this is basically saying that ggplot2, based on these aesthetics, I want gender and whether or not they survive, and I want the relationship to be facet wrapped by P class. It's the easy way to look at it. The squiggly line basically means by, and then you define your column here. The labels actually based on that, it remains the same, the function remains the same, and the title, again, just the text that changes, the function remains the same. So let's go ahead and run this and see whether there is a relationship here between gender and P class. Wow, look at this. We have a pretty good plot here. It's an amazing plot. I mean, let's look at the story. What is the story behind this plot? Let's find a fact here. Wow. So again, if you're a third class passenger, a male passenger, there is the least likelihood that you will survive. So if you're on board the Titanic, don't even try. If you're in third class, don't even try. Just let it go. Of course, if you're a female passenger, wow, this is the most likely that you will survive if you're in the first class. You get onto a lifeboat and just shoot off in the sea. I guess we have pretty good facts. So we've got two major facts here. Looking at the second class passenger, again, male passengers are less likely overall to survive. It's pretty difficult for male passengers, and female passengers are given preference to get off board, and there's a 50% chance that you will survive if you're a female passenger on the third class of the ship. We have quite a lot of context. This is great. I'm excited to look at Titanic dataset, and this is actually the first time I'm actually really looking at the story. To be frank, I've run the script before, but this is the first time I'm actually drilling down into the story and pointing out the facts. So it's exciting. Okay, let's move on. We've looked at. I think we've looked at enough bar charts. Let's move on to something else. Let's look at a new chart. Let's look at a histogram. And again, we'll ask ourselves this question: what is the distribution of passenger by age? Okay, this is age. So we're moving on to numeric columns from categorical columns. So age is obviously a continuous numeric variable in the data set. And let's look at the distribution in the data set of what are the ages of the passengers on board the Titanic. Again, let's use the copy paste reuse method. We define the data set, the aesthetics mapping equals age. So we're basically marking a numeric variable here, defining the theme. And here we will say geom_histogram, and which means that we will be using the layer as a histogram. So the layer is defined as a histogram. And what is bin width? If you are familiar with histograms, you would know what a bin width is. But bin width is basically the intervals you would want between in the scale. So basically, you want the relationship of the plot to be in intervals of 0 to 5, 5 to 10, 10 to 15. In those buckets, do you want it in the buckets? So if you can easily change it and make it whatever number you would like to define. So if you feel like your database is your data set is much vast, you would want to create intervals of 10 or 15 years of age, then that makes sense. But here, because we just have 891 rows, you'll just go with the least number, and let's look at the distribution. And of course, the histogram pattern changes based on the bin width. So if you have a bigger interval, you would actually have a different pattern on the histogram. So this majorly affects how a histogram looks. So you might want to take that into consideration before you actually can create a histogram. Let's run this and have a look at the histogram. Okay. Most passengers were between the age of 20 to 40. Let's zoom into this. So these intervals are basically intervals of 5 years, 5 years, and 5 years. I hope you get the idea of bin width. And many are actually, you can actually see that there are less people here between age of 15, but there are certain children as well, and most people are between the age of 20 to 40. There's a lot of passengers between 20 to 40 years of age, and as you see, it's slowly trickling down, but we have quite a lot of elderly people on board as well. Wow. There is a variation, definitely a pretty good distribution here. So you have an idea how many people are middle-aged, how many people are children, how many people are elderly on board the Titanic. You get a certain idea of the distribution. Okay, let's move ahead. Let's look at some survival rates based on age. So, can we differentiate whether people survived or died within this histogram? Is there a relationship between age and whether or not people survived? Is there a pattern there? Let's find out. Let's explore this field and see how we come out. Of course, we're using the fill function here again, which equals survival, and the only difference is we're doing a histogram instead of a bar chart, and it's just the labels change. We define the X and Y labels and the title. So let's run this plot and see what facts we can find here. Oh, okay. So if you're between the age of 20 to 40, most people, there is a pretty less chance of survival. I think most people perished between this age. Wow. There is children, actually. Children, there is a highly likelihood of survival if you're a child on board the Titanic. And well, there's a steep drop as it goes onto the age, and you can see here most people between this bucket actually did not survive at all. So that's pretty sad. But yep, we have a certain idea now that how is the relationship affecting by age. We can clearly see the distribution here. Can we drill down further? Can we facet wrap this? Let's look at our next question in our story. Before we actually facet wrap it, let's look at a box and whisker plot. Again, we are just changing the function here to box plot from histogram, mapping the aesthetics, and defining the labels. These are the basic basic steps to create a plot. Okay, is there drilling down? Okay, if you're between the age of 20 to 40, you have some idea that you will not survive. There is a little bit of difference. It's a lower likelihood of survival if you're between 20 to 40, but you can see here there is a huge difference for elderly people. There's a huge gap here, and wow, for children actually it's a continuous line. So this is what is called a box and whisker plot. Let's move forward. This is great. We are getting facts, noting them down to present it to the cruising company. Moving on, let's create a density plot. Looking at our question here, density plot is actually similar to a histogram. So it's basically a smooth line instead of a box. You're basically, instead of bin width, you're just defining the alpha based on because you need a smooth line. So that's the only difference. And you're facet wrapping based on sex and P class. Let's look at this. And you're also filling it based on survival. You're color coding the plot, whether or not these people, defining the classes and the gender, whether or not people survive, and by age too. Wow, we have quite a lot of features here. We have gender at play, we have the P-class, a numeric function, age, and whether or not they survive, and a density plot. Let's run this, have a look at the density plot. Wow. Okay. This is actually pretty fascinating here. This curve here, if you're a male passenger at a lower age between 1 to 10, there's a highly likelihood that you will survive. Children, male children on board the Titanic, most children survive. So that's great. It's good to know. in second class, obviously, and first class children did not survive. In third class, there is a highly likelihood. There's a comparison here. If you look at it, these lines are overlapping each other, so you know that if there's a relationship between survived or died right away. As you can see here, female passengers have a likelihood to survive, but actually many female passengers also died. So there is again a very close gap, but close to 50% females actually died on the Titanic. So this is great. This is an awesome discovery for me, at least. I hope you guys are enjoying it. Let's move on. Let's move on to a little more in detail, but instead of a density plot, let's do a histogram with bandwidth equals 5. We'll look at the same features, except that we're using a different way of visualizing. We're just defining a different layer here with different with the same titles. Okay, so I actually like the smoother lines much better, so you get a better context. But you can see here those where actually density plot actually illustrates the overlap but a histogram actually just does not illustrate an overlap here. It basically covers the overlap and doesn't show you how many people are overlapping. So overall, there is a trend. Most people died on board the Titanic. So going back to our first plot, less likelihood, close to 38% of less likelihood of survival on board the Titanic. All of this drill down basically now basically assures us that, okay, we were right on our first plot. I think 38% survival overall. Okay. So this is the end of the Titanic visualization, the visualization of the Titanic dataset. I'm going to load up the H1B dataset now. This is actually a huge dataset. So it's close to 410,000 applications and 52 columns. So most columns are defining the employer name. Okay, so well, that was fast. Actually, I expected it to go a little longer to load up. This is again a unique identifier. Case status, basically, this is basically the status of whether an application was withdrawn, certified withdrawn after applying, or it was approved or certified. It's a basic status. It has four categories, and it has a pretty detailed explanation in the metadata checked into the repository. So I would not be able to go through all 52 columns here, but you actually have a reference point in the repository to go back and look at what each column means here. So let me go ahead and dive into a visualization. Of course, this is basically we are defining some advanced functions here, but let's I will gloss over a few things, but let's try to stay onto plotting and looking at the overall story. So I will go ahead and set up these column names as categories, as factors, and this one column as numeric, and let's look at the head. Wow, it's a huge data set. It's pretty much 52 columns here. So it looks like our data set is loaded, our formats are set. Let's look at some employment trends. So I'm defining the data here. It's the H1B data set, which is loaded on here. And defining the aesthetics, the x-axis equals employer state. So if the company is in Washington state, it would equals X, or Texas or California, it would be the x-axis. And filling it based on case status. Let's see how many were denied, how many were certified, and how many were certified withdrawn. Of course, we are again just doing the basic theme and a bar chart with some labels. So this is again, this is going to give us a great sense of employment trends within United States. Wow, this is a pretty comprehensive plot here. Wow, California has a high employment rate of foreign workers. So, and New Jersey, and the same with Texas. Washington is kind of in the front runners, but a little bit lower here. But well, you get a certain idea. If you're a foreign worker looking for a job in United States, you know which state to head to. It's either California, New Jersey, or Texas. It's very clear. So you see how these facts can help us just using real world data sets. So this data set is for fiscal year 2018. It's a public data set available on the US Department of Labor's website. And just by exploring this data set, you get some perspective of what's going on, what's going on in the country with certain companies and certain employment rates. You get a sense of how do you approach if you're a person looking for a job. So you get some perspective here. That's the idea, basically. Wow, there's quite a lot of them certified in California. Overall, across the board, I see that many of those applications were certified. Of course, these are not approved visas. These are just certified applications. We still don't know how many of them were actually issued the visa for this year, but you get a sense of if you're applying, there's a high likelihood that you will be certified the application. And if you apply in these 3 states, it's a likelihood that you will get selected as a foreign worker. Okay, let's move on to some subsetting. Actually, I had loaded the dplyr package when we started off our script here, and we will basically be using the dplyr package to subset our data. We've looked at the applications. Let's just subset the certified applications. So this basically is a pipe operator in the dplyr package. So you can add multiple functions using this operator. So again, you're just defining the data set, adding a filter based on case status equals certified, and just subsetting the data. Let's subset it. Okay, I see that there's about close to 372,000 applications which were certified. And now we are basically creating a function. Based on this subset, we will create a function and use this function to plot with ggplot2. So you see how dplyr package works with ggplot2 seamlessly. I'm actually creating this function of top n employers. I'll basically to run this function within this plot. So let's go ahead and run it here. See under functions that this exact function is saved here. So you don't need to actually write the function within the plot, but actually just use the name and define the number. How many employers do you need? Let's get the top 10 employers in US and see who are those employers, who's filing these applications. Let's have a sense of that. Of course, there's some more details to this plot, which I will just gloss over. Like I've mentioned it on my slides that there's 6 aspects to creating a plot, and we are basically using 5 or 6 of them in this plot, like defining the layers, the coordinates, of course, and you can also define the scale here, and the title, theme, and the labels here. Let's run this. It might take a while. Again, it's a huge data set. So, and we might be able to see the top 10 employers who are employing foreign workers in United States. Of course, I'm expecting that most companies will be software companies because IT plays a major role in United States. Software is a big industry here. Oh, it's a basic bar chart. So it's taking some time to load, but top 10 employers with most applications. You can see how customized this plot is, right? I mean, so you have the numbers at the top of the bar, you have the company's name, and you have different levels of this. This is great. Wow, Google is on the top 10. Google is one of the top 10 employers for foreign workers, and the top number 1 is Deloitte Consulting. Wow, you get some perspective which companies to apply to. If you're looking for a job, you know the top 10 people employing foreign workers. Here it is. You have some context. This is great. Let's move on to something else. Let's see what kind of roles are these employers looking for. Again, I will actually create a function using the dplyr package. We'll first create a function for this subset and save it. So you can see top and SOC. So SOC here is basically the job title which was applied for that person in that application. It's a terminology used by US Department of Labor, so that's how they've named this column. And SOC name is the column name for job titles. Okay, let's look at this plot. This is a little more complicated here, but it's still using the geom bar plot and identify as basically defining some more advanced functions, advanced functionality here, setting the coordinates, defining the scale, and here we have some labels too, geom labels. So probably some more advanced functionality within the layers. We have some labels. The title, again, we are basically defining the theme here. Now we have some customized theme. Apart from theme.wb or bw, we are basically defining some theme, which you can actually learn moving forward. This is some advanced functionality and basic labels here. Wow, that was fast. Wow, software developers. It's a pretty big difference here. If you're looking for a software developer job in United States, in one of those top 10 companies, you're most likely that you will, your application will be applied. I mean, you will be moved forward to work in the United States. You will be applied for, and you will be comfortable. This is great. So you see here what kind of roles these companies are looking for. You get some perspective. So this actually concludes my data visualization part of my presentation. I would actually like to emphasize on storytelling. Storytelling actually plays a huge role when you're exploring your data. If you're not able to explain and create a story out of your data, it's going to be really hard for you to present it to someone or create basically facts out of it. You have facts, you need to create a story out of it to present it to your higher management or get some justification for that data exploration. So I would definitely emphasize on creating a story out of your data. And I will move on to show you a visualization. Within the GitHub repository, I've actually checked in a visualization here, which gives you it's basically a thought starter, like I've labeled it here. It's a thought starter. If you don't know what kind of visualizations you're looking for, you have some idea now based on some categories. You can create relationship tables, relationship plots, comparison plots, distribution plots, or composition plots. So you have some idea about how to categorize your plots. So you can, this is basically a thought starter if you want to dive deep into your data and visualize it with different layers. This is a good way of doing it. And thank you all for being here. I will give it back to our marketing manager, Blair.
Perfect. Thank you again to Arham, and thank you for everybody for joining. If you would like more tutorials and content like this, you can follow us on Facebook, Twitter, Instagram, and LinkedIn. You can also find more tutorials available at tutorials.datasciencedojo.com. For more information about our boot camps, you can hear about what past attendees have to say at datasciencedojo.com/reviews, or alternatively, you can set up a time with Arham or myself to inquire about our boot camps and curriculum. Again, thanks to everyone for watching, and we'll see you next time.